Now we're going to examine the fiber channel domain. Each vSAN has its own fiber channel domain. Each switch within the fiber channel domain has its own fiber channel domain identifier. And then the fiber shortest path first routing protocol that's used in SAN networks is going to use the fiber channel domain ID to identify the different switches and then calculate the best path between switches so that it can route traffic within the SAN. In this video, we're going to examine how it works. By default, each vSAN is going to elect a principal switch that will hand out domain IDs to all of the other switches in that vSAN fabric. And this is very much like DHCP. The principal switch's job is to be the one to assign the domain ID to all of the other switches in the vSAN. And not just any domain ID, but the principal switch has to make sure that each switch in the fabric vSAN gets a unique domain ID. This domain ID is used with the fiber channel ID that is assigned to each device that logs into the switch. When you connect to a fiber channel switch, that switch is going to give you a fiber channel ID, and part of that ID is comprised of the domain ID, which is unique to that switch within the vSAN fabric. Fiber channel domains are configured on a per vSAN basis, and if we don't manually configure a domain ID on a switch, then switches are going to use a random one. Within each vSAN, the fabric is going to select one principal switch. The principal switch hands out domain IDs to all of the other subordinate switches. Switches are going to make fabric decisions based on these domain IDs. The principal switch selection is based on the highest runtime priority. The lowest number is the highest priority. The range is 1 through 254. The default runtime priority is 128. So as we can see in this example, we have a single fiber channel domain. We have 3 switches. They all have the same configured priority of 128. Well, since we can't select a principal switch based on the priority, since they're all the same, they're going to use the next criteria, the switch with the lowest node worldwide name. And as we can see in this example, that's going to be the orange switch. It has the lowest node worldwide name, and so therefore it's going to become the principal switch. The principal switch changes its runtime priority to 2. Hey, if you win the election, that's what you get. You're now going to have a runtime priority of 2, while all of the other switches will maintain a runtime priority of 128. When it comes to domain IDs, we can configure a fabric switch to make either a static or a preferred domain ID request. All switches in the vSAN fabric, or fiber channel domain, should use the same method. By default, the configured domain ID is 0, and the configured type is preferred. If we don't configure a domain ID on a switch, then that switch is going to send a random ID in its request. Hey, can you give me 79? And it will ask the principal switch for domain ID 79. As long as that's available, the principal switch says, sure, here, no problem, take 79. But if it's not available, if it's been associated to another switch, the principal switch will then pick another ID. Sorry, that ID is not available. How about ID 5? And that's how fabric switches get their domain ID. Coming up next, we're going to examine fiber channel configuration.